This is video 251, and our objective in this video is to be able to find the factors of polynomial functions in order to solve. So our ultimate goal is to solve polynomial functions, but in order to do that we need to factor it. So we're going to talk about quick ways to factor them and to narrow in on the right solutions. So here's the first thing you need to know, that if you divide by x minus c, a polynomial, by the way, if you divide a polynomial by x minus c, you get a remainder of 0, then x minus c is a factor of the polynomial. Okay, so this remainder of 0 is basically saying, hey, I divide and I divide evenly. So in this case here, in this example, apparently if I divide by x minus 3, or 3 in synthetic division, I'm going to get a remainder of 0 because they're claiming that's a solution. It's going to divide evenly and give me a remainder of 0. Meaning, if I plug in 3, I will get 0. So let's try that. Let's see if it works. Using our synthetic division, we're going to drop the 2, multiply, and add. Multiply, 3 times 3, 9, negative 11 plus 9, negative 2. Multiply 3 times negative 2, I get negative 6, and I get 0. Remember, the coefficient on the original term here is 1 less than the original in the polynomial, so it'll be x squared. This is x and minus 2. So what we're saying here is that x minus 3 times this plus 0 will give me this polynomial. Because that's what dividing is. It's saying what times that number will give you the original answer. And so since that remainder is 0, then I know that x minus 3 is a nice clean factor of the polynomial. So I've got my polynomial starting to get factored, and we know to solve polynomials in quadratics you need to factor, and you need to use the zero product property. So right now I have one factor, x minus 3, times this polynomial, 2x squared plus 3x minus 2. So I have this factored because x minus 3 went into it cleanly. And that's the factor theorem is basically saying. Now we have one solution, 3, but there might be up to 3 because the power is 3. There might be 3 zeros, 3 points where this polynomial would cross the x-axis in order to graph it. So I need to check in this one and see if there's any other way to factor this. I'm going to kind of guess and check out loud and kind of share my strategy with you. I know the only way to get 2x squared is 2x times x. So my first term for sure gives me 2x squared. My final term has to give me negative 2. So something has to be negative, something has to be positive. And because of that 3 there, I'm going to guess that this has to be 2, and this will be 1. And even further, I'm going to guess this is 1, this is plus, and then it's minus 1 here. And I check my work, of course. Let's see, I'm going to get negative 1x here. My outer terms will give me 4x. They do add, in fact, to 3x. And then on my outer term, I do get negative 2. So I am set. This is a proper factorization of the polynomial above it. Now I'm going to take and use that to help me find the last 2 zeros. So I have x minus 3. That gave me a solution of 3. I have this solution here that's negative 2. And I have the solution here where x is 1/2. If you don't see why that is, remember we solved the equation when is 2x minus 1 0. And we solve for x and get 1/2. So I found my 3 solutions by factoring. But the trick is, the problem won't always be that easy to factor, nor will they gave us something here. They gave us that the 3 was a 0. So how do we figure it out if they don't give us a 0? Well, here's what we need to know. That the rational zero theorem, basically we're going to figure out a way to narrow in on the possible zeros of a polynomial. Now we're talking about integer zeros. Nice clean numbers, not 6.2 or negative 1/2. We're looking for numbers like 1, 2, negative 5, negative 11. Nice whole numbers and their opposites. So possible zeros of a polynomial can be described as p over q, where, let's see, so p over q. So it's a fraction, but it's only whole numbers, so it has to simplify to a nice fraction, where p is the factors of the constant term. So we're talking about a polynomial here, and we'll look at our example to understand. This is the constant term. It has no x value. So what are the factors of the constant term in this case? Well, positive 1 and negative 1 divide evenly into 4. Positive 2 and negative 2 divide evenly into 4. And then the final factors are positive 4 and negative 4. Those are all the factors of 4. The factors of, for Q, we look at the factors of the leading coefficient. So once again, we look at that leading coefficient. In this case, it will be a negative 1x to the fourth. And we're going to take a look at it and think, okay, what are the possible ways, what are the possible factors of negative 1? Well, there's only a few, so this one's going to be a little bit easier than we might have thought. So it's either plus or minus 1. Okay? In dividing these, so all these possible answers for P, all these possible numbers for Q, we basically need to look at all the possibilities for P. Because anything divided by 1 is just its number, anything divided by negative 1 is just its opposite, and we've included all of those in this list. So we have 6 things that we're going to guess and check with. So now, how are we going to guess and check? We're going to guess and check using our handy-dandy synthetic division. Okay? I'm going to guess that maybe 2 is a possible 0. So I'm going to test 2 into my polynomial and see if it works. I'm going to test 4. I'm going to test negative 4. I'm going to test negative 1. I'm going to test any ones until I come up with the right solutions, until I end up with my results. So I'm going to test 2 right now. Let's see, I've got negative 1, 0, because there's no x to the third, 3, 0, because there's no x power, and 4. And now I'm going to use synthetic division to see if this is in fact a 0 of my polynomial. So let's see, I'm going to drop the negative 1, times it to get negative 2, add it, 2 times negative 2 to get negative 4, add to get negative 1, 2 times negative 1 to get negative 2, 2 times negative 2, I get negative 4, and then I get 0. Now once again, that factor theorem comes into play here. Because the remainder was 0, that means that I have successfully found a factor. And this means that the polynomial can be written as x minus 2 times this guy right here, this polynomial. So let's see, I drop the power once, this is x to the third. So negative 1x to the third minus 2x squared minus x minus 2. I've successfully factored it into a binomial times a cubic polynomial. Okay, so now I'm going to do it again. I'm going to guess again. Okay, so I've already done 2. Let's try something else. Let's see if maybe negative 2 goes into it. But the good news is now I work with this smaller one because I've already divided by this guy. I just need to factor the other guy a little bit more. So I'm going to work with the smaller one. I'm going to check for negative 2. So I'm going to record my coefficients. I'm going to see if negative 2 goes into it. So I'm looking with the second polynomial here and trying to factor it further. Drop the negative 1. Negative 2 times 1, I get 2. Negative 2 plus 2, I get 0. Times it by negative 2, 0. Add it. Times it, negative 2 times negative 1 is 2. And it looks like I found my other factor. So now my factors are x minus 2, which is my original one. This minus 2, remember, means that it's x minus a negative 2 or x plus 2. It's the opposite of what we think. So this original polynomial here can be factored even further into x plus 2 times, let's see, once again I'm going to drop this 1, so it's now x squared, x and a constant. So it's negative x squared minus 1. Negative x squared minus 1. Okay, so I've got 2 common factors. I've got 2 solutions, 2 and negative 2. And now I want to check for this last one. This one is a quadratic, so now we go back to the basics. We can use quadratic formula. We could use 0. We could factor it further, or I'm just going to do this because I see that the x term is missing, and I'm going to say, hey, when is this 0? And I'm going to solve this polynomial or this quadratic in a slightly simpler manner. add 1 to both sides, divide by -1, and then I realize I'm going to have imaginary solutions. So this is not factorable, and therefore I have only 2 zeros, 2 and -2 that I found earlier. So my solutions here, I got lucky and I guessed the right answers. Sometimes you will guess wrong, and I'll show you some scenarios with that in a moment. So my 2 solutions are x equals 2 and x equals -2. Those are the only 2 zeros of the polynomial. Okay, let's look at our final example here. We have an example with x to the 4th minus 6x squared minus 8x plus 24. And it simply says solve. It's not a function that you're going to graph. It just says solve. And the only way to solve is if we can factor this. So using our rational zeros, we're going to look only at the factors of 24 divided by the factors of, well, 1. Well, that's good because 1 only has positive 1 or negative 1. So if I simply look here, I have a list of plus or minus 1, those are factors of 24, plus or minus 2, plus or minus 3 goes into 24, 4 goes into 24, 6 goes into 24, 12 goes into 24, and of course 24 goes into 24. This is a long list. Okay, so this can look a little daunting. It's definitely a long list. It's definitely something that I am going to cringe when I make that list. But now I'm going to take a look and just make a guess at something that I think is a factor. So I see the number 6 and I think maybe 3 is a factor. I don't know. I'm going to make a guess. I'm going to guess that it's probably not the extremes, like 24. So let's try 3. We fill in our synthetic division 1, 0, because there's no x to the 3rd, -6, -8, and 24. And I'm going to use my synthetic division. 1, 3, 3, 9, 3, multiply to get 9, add to get 1, 3, and I get a remainder of, way too big, 27. So I quickly realized that this is not a factor. 3 is not a factor. So maybe I try -3 right away, because it involves just changing a couple of things. -3, that'll still be 9, so that's interesting, but that'll be 3. Testing -3 now. I'm going to get -9, -17, positive, let's see, 3 times this is 51. So once again, I do not have a factor. So 3 and -3 are not factors of are not solutions to my polynomial. So now we try 2. I don't know, something small. Smaller numbers are easy to work with. 0, -6, -8, 24. Drop the 1, 2, we multiply, -2, we multiply, -4, add -12. Oh, looks like we got it. 0. So x minus 2 is a factor. So far we have x minus 2, and we have a new polynomial here that we can work with that's smaller and going to be faster. So my polynomial is starting to factor into x minus 2 times something. And in this case, the something is here. So we're going to continue factoring this guy. -12. And we're going to make another guess. Here's where I want to pause you for a moment. This is interesting that sometimes polynomials have factors that repeat themselves. Remember, that means that on the graph, it's going to go down and bounce back up. So I'm going to test every once in a while for repeat. So let me see. I'm going to test for a repeat of 2. If I do 2 again, will it work? If it works again, that means that it's a repeat, and my polynomial is not only going to have x minus 2 in it, it's going to have x minus 2 squared in it. And if that's the case, then I want to be aware of that. So I'm going to test for that right now, real quick, see if it happens. 2, add them, I get 4, multiply them, I get 8, add them, I get 6, multiply them, I get 12. So x minus 2 squared are 2 of the factors. And now we're at the point where it's x to the x squared plus 4x plus 6. Once you hit quadratic stage, you can either continue factoring if you like it, or you move on to using your quadratic formula. So don't run out of time. Here are your checkpoints.